Okay, I promised you to give you the proofs of the addition and subtraction identities. We're going to start by proving that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. If we look at two angles on a circle, let's say alpha and beta, there's alpha, then this would be the point cosine alpha plus beta, sine alpha plus beta. This may work out to beta minus alpha instead of alpha minus beta, we'll see. But that'll be the same identity anyway. So let's look at this. I'm going to rotate this a little bit. I'm going to rotate this so that this angle is beta and this is minus alpha. So that means this arc length is equal to this arc length and this arc length is equal to this arc length. That also means that this chord on the circle would be the same distance, same length as this chord, if this is both the same circle, the unit circle. Now, we can use the distance formula. If you recall, the distance formula is distance between 2 points is the square root of x1 minus x2 squared plus y1 minus y2 squared. We can use the distance formula from here to here, and this is cosine beta sine beta, and this is cosine negative alpha sine negative alpha. And if you recall from our identities, our negative angle identities, cosine negative alpha is the same as cosine alpha, and sine of negative alpha is the same as negative sine alpha. So we're going to use the distance formula and show this distance and this distance are equal. So the distance from here to here is going to be given by the square root of, and this is going to be x1 minus x2, so cosine alpha plus beta minus 1 squared plus, this is going to be sine alpha plus beta minus 0 squared, so it's just going to be sine alpha plus beta squared. And over here, that has to equal the distance from here to here, which is going to be cosine beta minus cosine alpha squared plus sine beta minus negative sine alpha, so that's going to be sine beta plus sine alpha squared. Over here, if I square this, it's multiplying it by itself, so I end up getting, we can go ahead and square both sides also and get rid of the square roots. So we have cosine alpha plus beta minus 1 squared plus sine squared alpha plus beta equals cosine beta minus cosine alpha squared plus sine beta plus sine alpha squared. If I go ahead and square this, I get cosine squared alpha plus beta. If you multiply cosine alpha plus beta minus 1 times itself, you'll get cosine alpha plus beta, so cosine squared alpha plus beta, minus cosine alpha plus beta minus cosine alpha plus beta makes minus 2 cosine alpha plus beta. And then we'll get plus 1, and we have our plus sine squared alpha plus beta. We're going to go ahead and simplify that, then we'll expand these. So cosine squared alpha plus beta plus sine squared alpha plus beta we know equals 1. So this becomes 1 plus 1 minus 2 cosine alpha plus beta, or 2 minus 2 cosine alpha plus beta. That's the left side. On the right side, we square this first, and this is going to be cosine squared beta minus 2 cosine alpha cosine beta plus cosine squared alpha. That's when I multiply this times itself. Then I'll square this, multiply it by itself, and I get sine squared beta plus 2 sine alpha sine beta plus sine squared alpha. Now here I have cosine squared alpha plus sine squared alpha, that's 1. Or sorry, cosine squared beta plus sine squared beta. Here I have cosine squared alpha plus sine squared alpha, that's 1. Those are gone. And then I have minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta. Looks like what we're actually going to prove is the addition identity. And then we'll work with to prove the other. These two things are equal. So this is 2 minus 2 cosine alpha plus beta equals 2 minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta. I'm going to go ahead and divide everything by 2 here. We'll subtract 2 first and get negative 2 cosine alpha plus beta equals negative 2 cosine alpha cosine beta plus 2 sine alpha sine beta. Divide everything by negative 2 and get cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. So actually what we set out to prove was, what we actually proved was cosine alpha plus beta. That's the cosine alpha plus beta identity that we showed you the other day. That's the proof of that. I can take this and I can say, to prove the cosine alpha minus beta identity, I can say cosine alpha minus beta is equal to the cosine of alpha plus negative beta. Then I can use this identity that we just proved to say that's the same as cosine alpha cosine negative beta minus sine alpha sine negative beta. We had the negative angle identities that we already used once, and we said that's equal to cosine beta. So this is cosine alpha cosine beta, and negative sine, or sine negative beta is equal to negative sine beta, so this becomes plus sine alpha sine beta. And that's the cosine subtraction identity. We'll use those to prove the sine. Let's show that sine alpha minus beta is equal to sine alpha cosine beta minus sine alpha sine beta. Let's start. Let's do the plus. Let's look at sine alpha plus beta. Oops. Is also equal to sine pi minus alpha plus beta. That's by our supplementary angle identities we did the other day. This is the same as sine, if we distribute that negative, of pi minus alpha minus beta, which is the same as sine of pi minus alpha minus beta. We can group this like this. sorry, I've messed this up. Let's look at cosine. Pi over 2 minus alpha plus beta. And recall that that's equal to sine alpha plus beta. That's what I was trying to do. But this is also equal to cosine of pi over 2 minus alpha minus beta, which is equal to cosine pi over 2 minus alpha minus beta. And we can use the cosine subtraction identity we just had and say that's equal to cosine pi over 2 minus alpha times cosine beta plus sine pi over 2 minus alpha sine beta. We'll recall our complementary angle identities, that cosine of pi over 2 minus alpha was equal to sine alpha, and sine pi over 2 minus alpha was equal to cosine alpha, and that's equal to sine alpha cosine beta plus sine beta cosine alpha, and that's equal to, because of the complementary angle identities, sine alpha plus beta. That's what we were trying to prove. And that's the sine addition identity. We can look at the sine subtraction identity, alpha minus beta, and use this addition identity and see that that's the same as sine alpha plus negative beta, which according to the identity we just proved is going to be sine alpha cosine negative beta plus sine beta, sine negative beta cosine alpha. And we know that cosine negative beta is cosine beta. And we know that sine negative beta is negative sine alpha, negative sine beta. And so that's the sine subtraction identity proven. So we've proven the 4 addition subtraction identities.